Hi, my name is Bernard Brault. I'm with OTN Systems, and today I want to talk to you about zero packet loss end-to-end. Actually, this is a live demonstration. It's the part of a training on zero packet loss that we're doing. So I'm not going to get into the details of how this works, but I'll give you a demo of how what it does, and along with a brief explanation. So what you see here is you see here an MPLS network, and what you have is X-strand device. Here you have a major substation. Because it's a major transmission substation, you may choose to have two MPLS nodes at this substation for complete redundancy, versus a transmission substation that may not be as critical, might have a single node, but in this case you may choose to have redundant power supply, redundant interfaces, and so on, but not necessarily have redundancy in terms of having two nodes. So what I want to show you now is if, for example, you were to do inter-substation goose messaging. So today you're doing like a mirrored bits to send transfer trip, or even you're still using transfer trips and current differential relay information between substation. In the future, that's going to be done through inter-substation goose messaging, and these are so important that they have to arrive with and when they're sent, you don't have the luxury of being able to retransmit them in the traditional fashion, where it would be sub 50 millisecond. And the way this is achieved is that HSR and PRP are standard protocols under 61850, and the concept is that they actually duplicate the frame. So you send two copies of the frame into two different directions in the HSR ring, and that's the case, for example, if you do sample values of your CTs and PTs, and the same thing with maybe goose messaging going to within the substation or even outside the substation. So the way it works is packets are sent in two different directions. The first one to arrive is actually processed and sent up into the higher level protocols, versus the second copy that's sent is identified because it's got the same destination MAC address, but it has a different sequence number. So either if the sequence number is different in the same destination, we know it's a duplicate. The other thing that can happen is maybe the duplicate doesn't arrive a certain window of time, and there we just ignore it because we know that maybe it was a long delayed because of a fiber cut or something like this. So the HSR protocol operates in a ring within the substation. The PRP protocol is a gateway protocol between HSR and the outside world. It works in a very similar way, except it's more flexible because you could build any type of mesh technology as opposed to just a ring within the substation. And finally, what you have between the substation is MPLS. Just to give you a different view of the substation, so what you see down there is the process bus, and at the process bus for a 61850 substation, in the old days you used to have CTs and PTs, and you would actually provide an analog feed of all the current values of the CTs and the voltage values of the PTs were directly fed to all the devices that need to have these measurements, versus now you have merging units, and these are digitizing this information and providing them in a redundant 0 millisecond recovery using HSR within the substation, and using PRP when you go up to the station level, and finally inter-substation using MPLS-TP. Alright, so let's get to the demo part. And here's the demo. Let me just bring the Ethernet testers. Okay, so this is a live demo. What you see here is a take care screen, and the devices you see, let me describe that. So you have, again, your major substation right here, and you got a smaller substation right there. And let's say inside the substation that you're trying to communicate a inter-substation goose message between these two substations. So here's a goose message between two IEDs that you're trying to transmit, and you want that to be 0 millisecond hitless, regardless of whether or not you get a fiber break or a cut or a loss of communication, let's say at this within the HSR, the PRP, or within the wide area network. So what I have here is I have two Ethernet testers. One of them is right here, and that's the top one you see right there, and it's connected to this RSP35. And I have at the other end, I have another Ethernet tester, and that one acts as a reflector. As you can see there, it swaps the MAC address, so whatever it receives, it'll send it right back, and that's for testing purpose. Now, describing HSR and PRP, if you remember, let's say for example that this IED needs to send a goose message on the other side, and because this is an HSR device, then the packets will be duplicated into both directions. So let's say a red one, and let's say its duplicate copy is green, so two copies are going to go out this way for the same goose message. And what happens is that it'll reach this RSP63, and this one is a gateway. So in other words, not only is it's going to actually continue sending it in the ring, but it's also a PRP gateway, so it'll send a copy up into, let's say, this PRP. Now the MPLS device here for the wide area network will actually take this packet, send it across down here, across the wide area network, inter-substation, and send it right back down there to this HSR PRP gateway. That's going to actually take this packet and then again send two copies, because remember the destination is that reflector down there that you see right here. And the same thing happens on the other side. The duplicate copy here that was originally from the tester is sent to this gateway. It's going to go across there, and it's going to go up here. And on the MPLS backbone network, you will provision this to go across a completely different path. And I'm just drawing this going across a microwave right here and back down there. And same thing. Once it reaches here, two of the two copies get sent, and you may question whether or not four of them are going to be sent, but actually once this packet reaches this gateway right there, it's going to get killed. Same thing with the red one, and it's because it gets recognized as a duplicate copy because it has the same sequence number and the same destination MAC address. All right, so let me clear this. Notice that what happens is that the first to arrive, the other, it's two packets get sent, but the ones that get discarded is always the late one to arrive. So right now, the fastest path that I have is literally this one right there, and that's the one that's currently. All the other packets are being discarded at some point, but this is the one that actually reaches the reflector and gets sent back to the original. And I'm measuring here the latency between the tester that's right here and how long the round trip takes, and this is shown right there as 370 microseconds. So what if I were to cut the fiber right there, right, in this HSR ring? What's going to happen is remember that a duplicate copy was sent in this direction. One will be sent up, but also the HSR ring is still going to be sending it in this direction. So, and I believe this is here still going to be faster than going all the way around this way. So if I cut here, I expect to see a slight bump increase in terms of round trip latency, because now we have one more hop to cross, and that's going to be the fastest one. So let's do that and show you what happens. Let's cut the right here, and between 62 and 63, hopefully I'll pull the right fiber, and let's take a look. All right, and Notice that the latency went up by a couple of microseconds. That's the round trip. Again, it's because right now packets are going up here, down there, up, and then this is the shortest path. So this is the shortest path. Why don't we cut the shortest path in the HSR ring in the second substation right there between these two IEDs, between 72 and 73. And again, it should take one more hop, so this should go up by a couple of microseconds. So let's cut 73 to 72. And there you go. And now you see we went up by 4 microseconds. And notice that we still have 2 paths across the wide area network. We have one path, that's this direct path right there over fiber, 1 gig fiber, and we have a secondary path coming down through the microwave right down there. So I'm going to cut this path right here, and what I expect is a substantial jump here in terms of latency, because we're going to have to go all the way around through the microwave. So I'm going to cut 200 to 220. So 200 to 220. There you go. And still 0 packet loss, but the latency, jumped to 425. So the only way between those two substations now, the only path left is through this microwave. I'm going to cut the microwave just to show you that this is real. And of course, if I cut the last, leg that's reaching out the smaller substation, there's no other path, there's no magic, so you cut all the paths, and then you'll see that now we're going to have a loss in terms of communication. So let me cut 210. I believe it's this one right there, and notice right there that we lost everything, right? So thank you for watching. I hope you enjoyed this presentation or demo of combining HSR deep inside the process bus, PRP basically being a gateway into the base station and into the substation bus, as well as combining this with MPLS into the wide area network. Have a good day.